Hello and welcome to ashford.com. You are watching an interesting video on specific neuron in the brainstem makes the neurotransmitter responsible for inducing deep sleep. Please read this disclaimer carefully. Scientists from Harvard School of Medicine, MA, and the University at Buffalo School of Medicine and Biomedical Sciences, NY, claim to have discovered a sleep node in the mammalian brain responsible for sending us into deep sleep. The team found that a specific neuron in the brainstem's parafacial zone, PZ, makes the neurotransmitter gamma-aminobutyric acid, GABA, which is responsible for inducing deep sleep. Next, they investigated whether it was possible to control these neurons by switching them on and off remotely. To do so required the deployment of groundbreaking new tools. These new molecular approaches allow unprecedented control over brain function at the cellular level, says Krista Lancelot, postdoctoral fellow at Harvard School of Medicine. Before these tools were developed, we often used electrical stimulation to activate a region, but the problem is that doing so stimulates everything the electrode touches and even surrounding areas that didn't. It was a sledgehammer approach, when what we needed was a scalpel. The level of precision required for this molecular control required the team to design innovative solutions. This included introducing a virus into the PZ expressing a designer receptor that only affected GABA neurons. Apart from the interaction with the GABA neurons, brain function was otherwise unaltered. Testing this designer virus in a mouse model, the researchers witnessed immediate results. When we turned on the GABA neurons in the PZ, the animals quickly fell into a deep sleep without the use of sedatives or sleep aids, says senior author and Harvard assistant professor Patrick Fuller. However, although the team reports success in their attempts to toggle this sleep node on and off, they have yet to pinpoint the exact interaction between these sleep neurons and other sleep and wake promoting brain regions. Publishing their results in Nature Neuroscience, the authors suggest that their findings may eventually translate into new drug treatments for sleep disorders, as well as potentially better and safer anesthetics. Carolyn E. Bass, assistant professor of pharmacology and toxicology at the University at Buffalo School of Medicine and Biomedical Sciences and a co-author on the paper, says, "We are at a truly transformative point in neuroscience, where the use of designer genes gives us unprecedented ability to control the brain. We can now answer fundamental questions of brain function, which have traditionally been beyond our reach, including the why of sleep, one of the more enduring mysteries in the neurosciences." Earlier this year, scientists at Penn Medicine in Philadelphia, PA, published research in the Journal of Neuroscience suggesting that lost sleep leads to lost neurons. In a mouse model, the Penn team found that extended wakefulness was associated with a lack of response from a protein important for mitochondrial energy production and that protects neurons from metabolic injury. After the mice endured several days of sleep patterns configured to resemble shift workers, the researchers observed a 25% loss of the neurons that regulate this protein, as well as increased cell death. References